All right. Hi guys. I was thinking about wiring diagrams, and one of the things I noticed with wiring diagrams is a majority of the machines you work with are computer controlled or have computer boards in them. And it's very hard to understand how the computer boards work sometimes. You're looking at them and all you see is just a box and a bunch of wires coming off of it. And trying to understand what it's doing is somewhat of a mystery if you don't have a real good understanding of just an electrical circuit to begin with. And I'm going to start creating some modules that have to do just with diagrams, and I'm going to work it so that there are going to be a couple of soft ones and get a little more complicated, but then I'm going to tie them in to an electronic version of the same thing and showing you, okay, well, this is how a mechanical machine works with a timer and switches. Now this is how the same sort of machine works with a computer board and electronic and everything else. I'm telling you that reading diagrams don't come to everybody right away. And having to look at diagrams takes a little bit of time. So I just wanted to bring up this here and talk about these parts. And then I want to say, well, how could we use this if it was, how could we make it computerized? You know, if we had all these mechanical parts and put all these mechanical parts together, if I was to make this same thing a computerized thing, how would I do it? So I want to talk about a couple of components. Then I'm going to show you a wiring diagram with those components on the diagram. And we're going to try to wire it up like the diagram. We're going to see the diagram and all the parts together on the same screen. And we're going to say, okay, this line goes to where? Okay, and then from there, where does it go? And we're going to build it. Then we're going to take a look at that and say, how could we do this electronically? How could we make this thing a computer board that does the same job? Because that's what these machines are. You look at a dryer, you look at a washer, you look at something else, the timer controls the motor, the heater, and everything in a dryer. A computer board does the same thing. It's just like an electronic timer. So I want you to compare and look at it and see how that goes together. So does anybody know what this piece is right here?
It's a relay.
It's a relay. And what two parts make up a relay?
You got
Switch.
A switch,
then you got line.
and you got what?
The lines that coming in power.
Well, you got a switch, that's what he said, but what other part is inside of a relay?
Contacts.
That's a switch. So we got a relay, which is a switch. Come on, you guys all did that in basic electricity. You remember all those boxes and you drew all those symbols and everything? There was a relay in there. What other part goes with the switch? What does a relay do?
Closes and opens.
How does it close and open the switch?
Through power.
Electric. Solenoid.
A solenoid or a magnetic coil. So we take and put a magnetic coil here, and then when I send power to this coil, it closes that switch. That's what that box is. Now if you guys look closely, I'm going to zoom in and make it big for a second so you can see it better. But if you look closely, they have information on that relay, okay? So let's take a look at this. Oops, I'm sorry. I have to change to my tool here. And let's make it bigger. Try not to make it so distorted. But let me get on this side here. If you look, that is the coil, and that is the switch. It's a 20 amp. It looks like a 480 volt, or it says 120 volt coil. But the switch could probably, I don't know if that's 200 or 400. It looks like 400.
400.
That switch can handle a circuit that runs off of 400 volts. But the magnetic coil here is 120 volts. And you barely see the little wavy line right there. That means what when you see a wavy line? What type of electricity?
That's AC.
AC, alternating current. So we got the coil and the switch, just like my diagram. They're not drawn exactly the same, but that's what that box is. Okay, so let me zoom back out. Just to get it all on the screen here. So here's our relay. And I put numbers on it because it's going to go with the wiring diagram that we're building. But how many terminals where we can connect wires do you see in this drawing here? Four. 1, 2, 3, and 4. You have a place to connect 4 wires. A lot of people get confused when they see this switch because it's not connected to anything and that line just up in the air. You know, they got to visualize that goes like this physically inside the machine. It's open and closed. Okay, but we got a switch and a coil. So 2 of these terminals are the magnetic coil and 2 of them are the switch. We could run it this way, and I'll just use a different color here. Let me see if I can pick a color. I don't know how to pick colors on this tool here. Give me a second. Here we go. So let's just say 6 and 5 is the switch. So between here and here inside, wait a minute. I thought I picked yellow, didn't I? Oh. This one is where I put yellow. Okay, so 6 and 5 inside this box is the magnetic coil. Now, the numbers may not be the same as my diagram that we're going to look at, but I'm giving you examples. So then, where would my switch be in that relay if 6 and 5 is the coil?
1 and 4.
1 and 4. So there would be a switch here between 1 and 4. So these 2 wires, when I put 120 volts here, they'll close that switch. Oops, sorry, I don't know how that happened. They'll close that switch and then that switch will send power to something else.
I thought it was the other way around where those 2, boom, you got power here and then.
I'm going both ways, just to
Okay.
show examples. It depends on the relay, okay? But in some cases, you have the relay going from here to here. You have the magnetic coil here between 1 and 6, and then you have the switch here between 4 and 5. Okay? You have to look at the relay. A lot of times they'll have the numbers telling you which one's which and what they are. Okay? Yes, sir.
But they got them on the microwave too, sort of like that, where they normally open and normally close, right?
That's correct.
Yeah.
And on a control board, the control board uses these relays to send power to a heating element, to send power to a motor, to send power to the water valve. That's on a control board too, that they have a bunch of them. You don't see the terminals here, you're just seeing a plug on the board that connects to these things. Okay, so that's that. I'm gonna leave it just like it is for now. What's that?
It's a microwave switch or
Well, we call it a micro switch.
Micro switch, yeah.
And basically, all that is a switch that connects here to here. Is that a normally open or normally closed switch
It's
as you see
normally
it?
closed.
Look closer.
Normally open. Look like it's normally closed to me.
It's open.
1, 2.
No, you see
Normally
it.
closed would be at the top. If you look, normally opens here and the common one's here. So the switch goes here
Oh,
from 1 to 3 and comes out here. There's nothing there at 2.
Okay.
It could have 3
Okay.
terminals,
Okay.
Was no milk.
but it only has 2 terminals. And
I
that's what I
thought
want.
if they connected, that's normally closed. Or even if you just put your meat on there, it'll tell you whether or not it's open. Normally
Yeah, but
open,
it
normally
says
closed,
NC here and NO there. So this
Yeah.
terminal is normally open.
yeah. Right.
What does that mean, normally open?
So when you press the button, it's gonna close. Right now
Yeah.
it's open.
So right now, the way it is, with the button popped up, just sitting here on the table, the switch inside is open. And then when something presses on it, whether you close a door or you pull a lever or whatever, and it pushes down on that button, then 1 to 3 close. Yes, sir.
Can you enlarge it again and show me how you can look at the markings and tell it's normally open?
Look at physical. We got common, which is the one on the bottom. 3 goes right to this metal pin here, and 2, where the line is, goes and there's nothing there. They do have micro switches. I can show you here. I do have it somewhere on one of these. Let me just pull it up on the diagram here. They do have micro switches that have 3 of them.
How do you
See this one?
determine what, if that's normally open or normally closed?
Well, it's normally open
One
and normally
side,
closed. It
yeah.
has 2 different terminals. So the switch is touching one, but not the other. When you press it down, it opens one and closes the other.
Right.
And how do you tell? On the other side of the switch, it's marked normally open, normally closed, common, whatever. But here's an example of that switch right there that shows the 3 terminals. If you look at it right here, can you see the one has 3 of them now? Top one is normally closed. The bottom one's normally open. This has 3 terminals on it, and the one I have in the lesson is a 2-terminal one.
So that one is normally closed?
It's both.
It's both.
It's the common, look at the drawing, 1 to 2, it's closed to the top one right now.
Mm-hmm.
The bottom one says normally open, so 1 to 3 is not closed right now.
Then you press the button, they flip.
Did you?
So when you press on the button, you can't see it, it's on the other side, this switch drops
So,
down.
yeah.
And then instead of it going from here to here, it's going from here down to there. Any other questions on that switch?
Oh, can you go back to the original switch?
Yes, sir.
So you're saying there's C for common, you're saying the 3 points to that terminal.
And the 2 is pointing to up here, which is, there's no terminal. They built the switch with just 2 terminals, we only have 2 wires.
So wherever you see the switch closed, whatever it's pointing to, that designates what type of switch it is?
Well, that's what we have the NC and the NO marking. We're telling it that if there was a terminal here, the common would be touching this one, that's where it would normally be closed. And this one here is normally where the switch is open unless it's activated.
So right now it's touching NC.
But there's no terminal there, so there's nothing going on. The switch is up in the air, but there's nothing up there. If we had a single pole double throw switch, which is the other one, has 2 throws, it would go up and make contact to this one, but the bottom one is not touching. When you press the button, it'll drop down and touch this one.
Is this switch normally open or normally closed?
This one here
Yes.
is normally open because it says normally open. We're looking at this terminal is
Okay.
at pin 3.
Got it.
Okay, if we had a terminal here, this terminal would be called the normally closed. This would be called normally open. This would be called common. Since it only has 2 terminals, we just say the whole switch is normally open or the whole switch is normally closed. Because we can find a switch that has this one on common and just number 3 and not number, no, I'm sorry, just number 2 and not number 3. That's a monitor switch in a microwave.
So in a microwave, like when you check in, okay, say with the monitor switch, that monitor switch, when you shut that door, that switch is always open.
Yeah, that opens, that's correct.
Right. So when you
That would be opposite of this one.
right, and in the other switch, the primary and the secondary switch, they would, when the door closes, that switch would be closed so you have power going to the board and other components like the
Yes.
light, the motor, and whatever else it goes to.
Yes.
But yeah, that's my method on knowing whether or not those switches are in the right place and stuff like that. I found them where that switch right there would be like all depressed and the contacts will be like burnt out or open and stuff like that. So yeah.
Okay, so get an idea of just a switch, normally open, normally closed, just a simple switch. Let's go to a motor, 240 volt motor. How many wires we got there?
2.
2. So if it's 240 volt, what wires would connect there to make it work? We call them what?
L1 and L2.
Line 1 and line 2. So we'd have 2 wires. We'd probably red and black from the power supply. But let's see here, drawing tool. So we'd have, let me just use a different color. I'll just use red and black for now. So I'll put black to one of them, and I'll put red to the other, and I'll call this line 2, and I'll call this one line 1. So if I put line 1 and line 2 to those two wires, the motor's gonna run. Okay? Pretty basic, pretty simple.
Did someone order food?
Oh, Joe, go. So, that's how the motor runs. That's it. You just put 240. There's other things going on with the motor, but just generally look at the motor. Now, let's take a look at.
So if that's 240, right? I'm thinking, you know what I'm thinking now? You got 240. I'm thinking like, okay, I'm thinking when I hear 240, I'm hearing 3-phase.
No, single phase. Because you got 240 single phase, which is just 2 wires,
All right.
and 243 phase has 3 wires. Okay? So, if we just put 240 to them 2 wires, we're going to make it work. Now, there's a wiring diagram on there. What is it? Single phase, right?
Mm-hmm.
Well, first of all, I'm going to tell you what this diagram is. Nah, you know what? Let's talk about wiring it first, and then I'll tell you what the diagram is and how this came about. All right? So, line 1 and line 2 is here. They say black and white, but it should be red and black or whatever, or blue and black or blue and red. But normally, code for line 1, line 2, and line 3 is line 1 is usually black, line 2 is red, and line 3 is blue. That's 3-phase. We don't deal much with 3-phase. That's usually used in commercial. Like our building, all those outlets we have, because we have so many 240 volt outlets, we have 3-phase. And we can put a couple 240 on these two, a couple 240 on these two, and a couple 240 on these two, and that's why we have 3-phase. But we got a motor over here, right? 240 volt motor. What 2 color wires do we got going there?
Yellow and
Yellow
blue.
and
Yellow and blue. We got a motor with a yellow and blue, right? Okay. What is this piece here?
That's 240 volt VAC coil.
That's this relay.
relay.
This box is this relay.
Mm-hmm.
And then what are these 2 switches here? Can you find those 2 switches on the diagram?
Right there.
Can you be specific as to what they are?
Push
Yeah.
button.
NO.
Push button switch
Normally open.
and
Yeah.
overhead
yeah,
limit
close.
switch. So they have, oops, I'm sorry. They have names, overhead limit switch and push button switch. So let's build this diagram. Let's take and draw these pieces, how electricity is going through them up top. Okay, and then I'm going to explain to you how this came about, but then we're going to look at the same diagram and we're going to say, how would it be if it was computer controlled? How would they do this on a computer, this same circuit? Okay, so power came in black and white. If I have, let's just say, I'm going to say black and red instead of black and white, just try to stay. I'm going to say this is line, oops, I'm sorry. This is line 1, and I'm going to change to red here, line 2. Or let's say the red is the white here. I'm gonna cross this out here and call this red, because that's the way it should be, not black and white. All right, now let's start off with the black wire, line 1. Look at the diagram. Can you see the black wire, line 1 on that diagram? Where does it connect to? This is the power supply in the wall,
Going
or
to
the
relay.
plug.
Going to the relay.
It goes where?
To the relay.
Pin 1. No, pin 1.
Relay pin 1. So if I took this diagram, oops, let me erase that a little bit. My touch screen here is not working too good. So if I took that, I'd run this here to pin 1 on the relay, right? That's this wire here to pin 1. Is there another wire connected to pin 1? Or is that the only wire connected to pin 1?
You got another wire coming from that normally open switch right there.
Well,
Going
on
to
pin 1, how many wires do I have connected there?
Look like two.
There's 2. There's one coming up from the bottom, and the other one's going where?
Going up to that,
Push button.
Switch.
So I'm just gonna go and, is it on the common or the normally open position on the switch?
gotta be on the common.
Why do you say it's on the common?
Because if it's gotta be on the common because that's where it's gonna connect to in order to shoot power for it to open or close.
Well, first of all, let me tell you one thing about a switch. If a switch only has 2 terminals, one here and one here, it opens and closes. It doesn't matter if I put the wire on this side and that side or reverse. Okay, if it's just 2 wires, 2 terminals, and it's just a single pole switch like this. But if we look at the diagram closely, you notice how the switch is, the actual part that goes up and down is connected to the circle on the left. So that is normally the common position, the part where the switch swings off of. If we go to the diagram here, can you see the diagram brings that little circle up top? I'll go back so you can look at that other picture we have of that switch. You see how this common goes to there? These are what we call the throws, and this is the pole, or also known as the common. It's the part that it swings on. Okay? So if we look at the diagram, the part that the switch swings on that's the common side. This would be called what? What terminal would it be called?
3.
NO. And normally open. So we're going to take a wire from here and I'm going to connect to the first switch. Which pin do I connect terminal 1 to?
Common.
Well, which one? The top one or the bottom?
Oh, bottom.
Okay, so then I take another wire here and run it like that. So that is this black wire here. You follow me so far? Everybody follow me how I'm wiring it? Okay, so coming off that switch runs to the other switch, right?
Mm-hmm.
So it goes from one switch to the other? And where does it connect to the other switch? It goes from the other switch, it comes out here, but it goes to the other switch, what side? Common or normally open?
No.
Going to
Normally
the common,
open.
going to the common side.
Yeah, normally open. And believe it or not, my bad, I should have had, that's a normally open switch, it's a normally closed switch. They didn't say NC, but look how this one is drawn in the closed position, and this one's drawn in the open position, so I should have had 2 different switches. I was in a hurry trying to put this together for you, so I didn't really look at the switch too close. But it goes to the common position, and coming off that switch goes to what pin? Pin 5. So coming off this switch goes to pin 5 here. So I'm going to take this wire, and it's a little hard. You know what? Let me redo this a little bit tighter. I'm going to take this one and go to pin 5, like that. Now, do you all see how I'm wiring this?
Mm-hmm.
Mm-hmm.
All I did was power into the relay at this point, and I went through the 2 switches and came back to pin 5 on the relay, right?
Mm-hmm.
Okay, so let's do the other power supply here, the red one. Let's go to red now. Red goes to where?
6.
6.
Pin 6, right? I put it right there, right? Is that the only wire on pin 6?
And the wire to the motor.
It
No.
goes to the motor, right?
Right, yeah.
So this one here, oops, that's not what I wanted to do. This one here goes to which wire on the motor?
Blue.
Blue. So I'm going to bring it here and bring the red wire to the blue wire. Oops. What a bad drawing.
You missed it.
I'm fired. That's it. I'm going home. I'm not doing this anymore. So like that. So we went from pin 6 to the blue wire on the motor. That is this wire from 6 to the motor. Now, whoops. I'm going to come up with some of these assignments for you guys, so you're going to have to do some of these a little more complicated and everything. But anyways, we still have pin 4, nothing connected on pin 4, do we? So what do we do?
The yellow to the
Yellow
motor.
coming from the motor to pin 4.
So then we're going to take yellow, and we're going to go coming from the motor. Oops. And we're gonna go, well, no. I'm gonna go yellow and the pin 4. And now it's wired up. I'm sure none of you have any idea what that circuit is for or what that.
That's what I'm saying. So if you just want that motor to run, we just go ahead and hook up line 1 and line 2 to that
Does
motor.
this
Just
work?
let that motor run, you know?
That's
Yes,
not-
you could. Yeah, go ahead.
Is that for like a vent hood or?
No, actually, believe it or not, it's a lift for a car.
You got micro
And this, and I want to bring up how this came about, and then I want to show you how it would be electronically, because I was thinking about diagrams. And I was saying the biggest thing people have a hard time following is diagrams, and the majority of the machines you all work on have computer boards. So you see wires going to the board, you see them going to the motor, you see them going to the lock mechanism, but you look at that board and you're just saying, okay, I see it's connected, I just don't get what's going on. I don't get how it's working and how it's doing what it's doing. Well, this thing here basically does the same thing when it's mechanical switches or whether it's computerized. And we're going to compare it to computerized, but we had someone installing a lift for an automobile in the Toyota lab over here today. And the guys didn't really speak any English, so I talked to them in Spanish, but the person in charge told me he had to leave, said, do me a favor, when they're done, lock up. Let's go over and check and see if they're almost done. So I go over there, and the guy's going in Spanish, broken English, no power, no power. I need power. Well, they installed the lift from the ground up, and they were connecting the wires, but the thing wasn't running. I said to the guy, you got a diagram? No. You got a meter? And he came out with one of those little wands, you know, when you go by the wire and it beeps. So he goes to the wire. What does that mean?
Power.
He's got power. He goes, oh, see power, see power. So he was afraid to touch it. Every time he was like this, trying to touch the wires. I said, excuse me. So he didn't have a wiring diagram. Okay? So if you didn't have a wiring diagram for something, what would you do? For the machine, what would you do? You don't have a diagram.
You go to where the
Hop-
power
hopscotch.
comes in.
You would be
start-
what?
You start where the power comes in.
No, but I mean, how would you get a diagram if you needed to get a diagram?
Pull it up.
Online.
Go to the internet.
Online.
But before you go online, what 2 things do I need?
Model and serial number.
Model, not so much serial, but at least the brand will help. Model number and brand. You want to know if it's a Whirlpool, a model number this, or a GE model number that. So these guys are messing with it. I get on my phone right behind them. John Bean. Model number, yada yada yada. Wiring diagram. Pulled up a whole manual. I got the whole book. Parts breakdown. It was made by Snap, or not made by Snap-on, but attached to Snap-on. And I got this diagram. I told the guy, hold up. And I'm looking at the relay, and I'm looking at the wires he's got coming in. And I said, one of them wires got to go to pin 6. Connect it. The other wire goes to pin 1. Connect it. Now, this overhead limit switch they had way up in the top of the lift, it wasn't connected yet. The wire was just hanging there. So this switch wasn't even connected. Well, you take that switch out of the circuit, and this coil's not going to work on the relay. The relay's never going to close. He's hitting the button, which is this one, and it's not doing anything. He's pressing the button, it's not doing anything.
Overhead switch.
So I told him, you connect this wire here, and this one goes to this one, and this one goes to that one. So I'm playing a joke. I said, go ahead, turn it on. And I run like I'm hiding behind it. Guy switches the breaker, presses the button. It took me 2 minutes, 3 minutes to tell him which wire goes where. But I was being able to read this diagram. This same exact, this is the diagram these guys couldn't figure out how to wire. Now, if you look at it, it's pretty simple now, isn't it? Just 2 switches, a relay, and a motor. It's not a very complicated thing. But if you don't know how to read the diagram or know how to connect these things together, how does this diagram work? Can you tell me what's supposed to happen? What's the process? By looking at the diagram, can you explain this is what happens, and this is what happens, and this is what's supposed to happen? Remember, it's a car lift and not a washing machine or something, but it's a diagram with switches and a motor. So what's supposed to happen? If you go to a lift and you want to lift a car, how do you make it go up?
Press a button.
You press a button, right? Looking at the diagram, which one of the buttons would you press?
Push button.
Push button, right? So you're going to go to the first one because that was the first one we connected to. You're going to press down on it and you close this switch. Now watch what happens. This line comes here, goes here. This one's already closed. This is the overhead limit switch. What that is when it lifts up a car, if it goes too high up and you're still holding the button, that switch opens up, breaks the circuit so it don't go up anymore. So we got to stop it before it gets too high. Okay? But we bypassed it. You press that button, and when you bypass it, where does it go? To the coil of the relay and out. So now we energize that magnetic coil. When I energize that magnetic coil, what happens inside the relay? I'm sorry?
It sends power somewhere.
Okay, but let's take a look. 6 and 5 is the coil, right? So let me use the white one. 6 and 5 is the coil. Well, that's a bad one. I can't even see it, so I'll just draw it this way. 6 and 5 is the coil. 6 and 5. The switch is 1 to 4, right? Right now, the switch is open. And you know what? Let me do it the other way. The one is the common position, right? Well, I don't even know. It doesn't have a comment, but it looks like this. Oops, I didn't want to move it. I don't know why it changed on me. And this piece, I'll go like this. So when the magnetic coil comes, it pulls that switch down and makes contact. So when I energize that coil, I close that switch. So when we energize this coil, when we push this button, power comes in, goes over here to this pin, the magnetic coil gets energized, and it has power as soon as I'm pressing that button. If I let go, it stops. Because that kind of switch will only make contact if you're holding it. But then when I energize that, what does it do here?
Close the contact.
Closes 1 and 4. So now power can run through 4, go through the motor, and back out to 6. So then once I close that switch, now I send power to the motor from the relay. Okay? So you press the button. One of them is to turn it on. The other one's a safety.
So that's a series circuit.
Those switches are in series, yes. They're in series with the relay coil. So let's take this. Hold on a second. I'm going to take this diagram. And let me just right click and copy with the mouse. It's a little bit easier. And let's go to the next screen. Oh, there it is. How would we do this? Let's say we wanted to make it computerized. We can do it many ways. Let's talk about one way to do it. First of all, let's draw a computer. Oops. I have to have something other than white. Now, if we look at this diagram, one side of the motor goes to power all the time. It does connect on the relay, but if we follow this blue wire, it goes right to line 2, right? So if I put a motor here, oops, that's not how you write motor. I put a motor there, right? And we're gonna have a blue and a yellow wire. I'm just gonna put Y and BU, okay? The blue and the yellow wire, right? The blue wire, even though it connects to that relay physically, it really just goes to line 2. So I'm going to go over here, power supply, two wires coming in. I'm gonna call this line 1 and line 2. Okay? Line 1 and line 2. So the blue wire goes directly to line 2. I don't have to put it on that relay. Watch. I go like this and put one wire here. That would be this wire going all the way back. I know it connects there to the relay, but it doesn't really go through the relay. It's just a place where the two wires are connected together. Right? Well, this board has to have a relay on it. So I'm going to put a little switch in there, right? That's that relay switch. That's 1 to 4. And power's got to come in to 1 and go out 4 to the motor, the other side, right? Oh, sorry. So if I go like this, 1's going to go to the relay on the board, and coming off the board is going to go to the motor. That's the relay circuit, right? But we have to have 2 switches on that diagram, right?
Mm-hmm.
Well, first of all, we have to have a push button switch. That could be either built onto the board physically, where like in some of them washers, you push the button, says push to start, and if you take the board off, it's connected right to that board. Or it could be a switch outside. Let's just say it's a switch outside, and you got 2 wires connected there. And so I got a little push button switch. That is, I'm going to say PBS, push button switch. And I connected it directly to the board, so when I press it, the board sees it, tells that relay to close. And that would be open, right? So if I was to draw it like a circuit, I would draw it like this. Push button switch, and it's open. But I have to have a safety switch on there, right? I don't want them to go up too high, do I? So I'm gonna make a plug here now with multiple wires on it. And I'm gonna run 2 more wires to a switch that's normally closed instead of open. That's my overhead limit switch. And the board sees it, right? So I can have those 2 switches connected to the board. The board sees that one's open and wait for me to press it. The board sees this one closed, and if it goes up too high, it opens it, turns that relay off. I'm missing one key component. Can anybody tell me what is missing? We have the board, we have a relay, we have the relay, we have the motor, we have the 2 switches, and we have a power supply. What is missing? What? No, there's no capacitor in that diagram.
Power to the board itself?
What?
Power to the board itself?
Power to the board itself. We do have one line connected to the board. We can have, what do they call that in the microwave, with that little thing on the board that we put power to? I said it the other day. It had 3 letters.
TC.
It started with an L.
Low voltage transformer?
Low voltage transformer. It said LVT. So line 1 could come in and go to a transformer on the board like this. But I need a place for that to go out. Where would that go? The other side of that transformer right here. Where would it go?
Neutral.
Not neutral. We don't have a neutral. It usually would be a neutral. We'd go to line 2. Very good. So we put it here in line 2 because the transformer on the board has power all the time. It doesn't get controlled by any, it might get a safety in series with it. There might be a safety here like a fuse or something, but in all appliances electronic, the boards are always on. Even if they don't light up, as soon as you press a button, they turn on, so there's always power to the board. You know, all these electronic machines, when you're not using them, are still using electricity. You know, the charger for your cell phone plugged in, you don't have a phone on it, it's still using electricity. Your VCR and, well, your VCR, whatever you guys use, DVD. I still got a VCR.
Not even DVD.
Home stereo system. Your TV's not on, but it's still connected. Your PlayStation's not on, but it's still connected. Okay? You know, you hit the remote, PlayStation automatically comes on. It's already powered, waiting for that controller to turn it on. So I said there's many ways we could wire this. This would be one way we would wire this. So this here would be the same diagram, but with a computer board. Look, only one power wire goes to the board to control the motor. We don't have both wires from the motor going to the board. We don't need that. We only need one side to turn it on and off. Now, for safety, I could remove this switch from here, take this switch out of the circuit, and if I want, I could put that switch here, the overhead limit switch. So then, if it opens, will my motor turn off?
Yep.
Yeah. So I could do that too, right? So I could have it either running off the board and have the board monitor it, which turns off the relay, but I'd have this switch here. Which one do you think they would do? Would they do the one here off the board, or would they put it here in series with the motor?
Off the board.
Off the board? How many of you say off the board? Wow, only 2 or 3 people say that. Why would you say it's not on the board? Anybody say it's not connected to the board to be connected the way I drew it?
I'm thinking about the microwave on the switch, that monitor switch on the microwave. It's off the board, and it opens up once it senses any.
Yeah,
type
but we
of
don't
heat.
need the monitor switch for the appliance to work. We could take the monitor switch and throw it in the garbage. The microwave's gonna work.
Well, you need some type of safety switch. That's like you said for that. You need something.
Well, it would more likely be here than on the board, and let me tell you why. Because if it's connected here to the board, if the relay on the board closes, and for some reason that relay gets stuck and doesn't have a way to open, because sometimes they get stuck. You have no other circuit until I put a switch here to stop that motor. Your push button switch ain't gonna do anything if that relay is closed and stuck. So this would be physically activated by the lift going up.
So that switch would be more mechanically
Activated instead of computer activated, yes.
So is that like how the Samsungs have that issue where the relay in the on the board gets stuck and it just, you can't stop it until you unplug it? Samsung drive?
I have not seen that, but how about those range hoods that come up from the counter?
Yeah.
If you've never seen them, we have, I don't know if we still have it, but we had one that went up and down, and it had micro switches. When the hood went up, it hit a switch so it doesn't keep trying to go up, and when it went down, it hit another switch to tell it was at the bottom and to shut off.
It's
Those
like
switches, one of them would be on the board telling the board to stop, and the other one would be here as a safety to stop the circuit from the motor just in case the board didn't do its job.
One of those things out there. That's the main function of those garbage disposals out there. Those compactors. That's the main function of those compactors.
Those switches tell it when they go up and down.
Yeah, and it'll stop it when it
So-
goes up too far.
The idea is computer boards aren't that far away from mechanical circuits, but you need to understand this mechanical circuit first before you try to take a computer circuit and try to understand all the wiring of a computer circuit. Because you can't see, normally they don't even show these lines here, they just got a plug like this. This is how you would see this. You'd have your relay on the board, you just see a black box like this. You'd have your low voltage transformer, and you would have this plug here with, let's just say, wires, and then line 1 and line 2 would be like this. Line 1 would come in and go to the plug here. Oops, let me redo that. Let's just do line 2 will come in here. Line 1 will come in here. This switch will be here. This switch will be there. And the relay and the transformer are on the board. They don't show you how that relay is connected to that board. They just show a bunch of plugs, and then this motor wouldn't be there either, would it? This motor would be here on the plug. So now you got this board, and you have a plug with all these wires. But that, how I drew it before, is how that circuit would work, but you don't see that when you're looking at a board. And you have to understand, all a board is whether it's a mechanical relay on the board or electronic relay like a triac, that power comes in the board and goes out to another part. But like this switch is connected to the board so that the board knows when to close that relay. So they're outside switches. On a washing machine, the water level switch connects to the board. That's how the board knows how much water's in the machine. The door switch on the washer is connected to the board, almost like this switch. That's how the board knows, hey, turn the machine on because the door's closed. So you have to understand, and you have to think that way about a computer board and about a mechanical circuit, and how that they are pretty much the same thing. You just can't see them. So you have to understand the mechanical circuit. If you can understand how current flows through in a mechanical circuit, then you can figure it out on the computer board.
And all that's DC, direct current, right?
No, all them wires are AC.
What about on the board? Everything on the board is DC. When you
Well,
mention
the board's low voltage, yeah.
yeah.
And that switch may be a low voltage switch, but the motor's not. Power coming in, transformer, the low voltage transformer is gonna drop it.
Mm-hmm.
Wait, the power that's going to the board is not coming from the outlet, which is AC? I'm confused how that's DC.
Well, the power coming in goes to a transformer, and then it drops it down, because computer boards themselves normally are low voltage. They only like 2, 3, 5 volts. On some machines, like some of the refrigerators we've lectured on, they were 12 volts, like fan motor or something coming off of that board. So you'd have 120 or 240 coming in, and the transformer on the board would lower that voltage, and there would be diodes on that board that convert it from alternating to direct current.
Transformers lower AC voltage, like into people's homes.
Yeah, but we have a transformer on a computer board that lowers the voltage on the board.
Right. So what? I don't get how it's DC voltage.
Well, transformers don't convert AC to DC. Usually that is done through this. You know what that symbol is?
Dial?
That's a diode. And diode will only let electricity go through one way. The other way it can't go back. So alternating current is going back and forth, but DC current only goes one way. So it can go through the diode this way, but it can't come back. The arrow's pointing to a wall.
DC could go through that way?
Alternating current, half of the current, one direction, can go through. When it tries to go back the other way, the diode blocks it. That's how we convert AC to DC volts. Some of the compressors are DC compressors, and we call that board an inverter board. The inverter board is converting AC current to direct current. It's usually through a set of diodes. What's the part in your car that charges your car battery?
Alternator.
Well, an alternator is generally creating alternating current. It's like a generator. You know, when the power goes out, you hook up a generator, it creates alternating current, same current in your house. But it has packs of diodes inside the alternator that control the pulses of electricity coming out and convert them from alternating current to direct current, because they only let one direction of that AC out. So through those little, if you ever looked at a board and you saw these little tiny parts on the board, they're capacitors and resistors and diodes. The diodes on there are the ones that are usually doing the conversion from AC to DC. How is that circuit configured? I'm not an electronics major. I can't tell you how to hook up a bunch of diodes and make AC DC. But I know how to hook up a board that converts AC to DC. Someone else engineered the board itself. That's not my job. But yes, you could have AC or DC coming into that board, usually AC, and the board converts it to DC.
So question, if that was a high voltage, transformer,
That was a high voltage transformer?
Yeah.
It wouldn't be on the board.
it would be separate.
It would be probably external. And on a microwave, we have a high
Yeah,
voltage
it's
transformer that's that big old block inside. And on the board, we got a little transformer. Any other questions on this? No? Okay, tomorrow I'm gonna do a little demonstration. I got a couple of these microwave control boards. And I'm gonna give you guys some stuff and we're gonna figure out how do you put power to the board and make the board light up. How do you use the board? Can I make the board turn on another part like this? I'll teach you how to use the board for other things so you get a better understanding of how the board works. So that's tomorrow's exercise, okay? No more questions? Okay, you guys get to work.
Yeah, the band, the rock and roll band, AC